the ground trembles. A shadow moves across an ancient plain. Leaves shiver. A river spits steam. Something enormous breathes. It is older than our myths. Older than our maps. It has ruled this world for 180 million years. We think we know its bones. We think we buried its story. But listen closely. There are still whispers in stone. There are still questions in the silence. And the last day, the last terrible day, comes with a single, bright scream from the sky. Don't look away. Because what follows changed life on Earth forever. Name: Dinosaur. Scientific frame: members of the clade Dinosauria, a sprawling, ancient branch of Archosaurian reptiles. They first appear in the fossil record during the Triassic. Roughly 240 million years ago, tiny, limb-stiffened reptiles step into a world of fern and flame. They will become rulers, shapes varied as nightmares and wonders, armored tanks that chewed ancient forests, long-necked towers that drank whole treetops, feathered hunters as light as ghosts, skulls crowned like war helmets. Size? Everything. The smallest were no bigger than a turkey. The largest reached lengths rivaling city buses and weights that crushed Earth's best estimators. Think of Argentinosaurus, a name that whispers continents, the titanic sauropod estimated at dozens of meters long and tens of tons heavy. Think of Spinosaurus, a fish-hunting leviathan. Think also of the sparrow-like ancestors that would survive it all as birds. Appearance varied. Scaly hides appear in some fossils. Filaments, protofeathers, appear in others. Horns, frills, spines, plates, beaks, teeth. Teeth like shears. Teeth like pegs. Beaks like shears. Claws like scythes. Every continent carried its icons, ceratopsians on one, hadrosaurs on another, theropods prowling between. Range and habitat, from polar forests that never slept, to desert flats baked under a ruthless sun, from river systems thick with crocodile cousins to islands rimmed by reef and storm. Wherever there was life, some dinosaur found a way to live in it. First discoveries: bones in the early 19th century snapped the world awake. Iguanodon, Megalosaurus, Hadrosaurus, names given by hands that had never seen Earth as older than theology allowed. Those first bones birthed a science and a rivalry. They built museums. They built arguments. They changed how we thought of time. This is a lineage, not a single animal. Yet the word dinosaur carries a singular, cinematic weight in our minds: the terrible, the colossal, the impossible. What did dinosaurs do all day? The fossil record answers in fragments: footprints, nests, bone beds, stomach stones, tooth wear, and the rest we fill with careful, testable imagination. Herbivores grazed and browsed. Hadrosaurs, the duck-billed dinosaurs, cropped low ferns and high conifers with battery-powered dental batteries, rows of teeth stacked like factory lines. Sauropods migrated like living mountains, stripping forests on a continental scale. Their feeding shaped landscapes. Carnivores hunted. Some stalked alone: T-Rex, a headline hunter whose bite could shatter bone. Others hunted in packs or family units. Some evidence suggests coordinated behavior in certain theropods. Others, like Spinosaurus, specialized, semi-aquatic, its long jaws full of fishy trophies. Claws, slashes, ambushes, the repertoire was broad. Some dinosaurs showed surprising skills. Birds teach us that feathers evolved before flight in many groups: insulation, display, even brooding. Feathers and filaments appear in multiple lineages, hinting at complex behaviors: courtship dances, lead brooding, temperature control. Social structure: herds, colonies, parental groups. Trackways, the fossil footprints left in mud, show mixed-age herds moving together, suggesting family bonds and protective behavior. Nesting colonies found in Badlands reveal communal nesting grounds, an echo of seashore bird colonies today. Daily life smelt of dust, sap, blood, and water. It tasted of leaves and meat and sometimes, the salt of fish. It moved to the heartbeat of seasons: rains, droughts, migrations, little different in rhythm from the animals that surround us now. The stagecraft of survival was ancient but familiar. Eggs, clutches, nests, brooding and abandonment all leave marks. Dinosaurs laid eggs, leathery in some, calcified in others. Eggshells preserve growth rings. Embryos fossilized curled inside. Some species built nests and returned to them, brooding like birds. Fossils of Maiasaura, the good mother lizard, show juvenile remains that grew quickly under parental care. That's one of the clearest windows into dinosaur parenting: hatchlings that were fed, protected, and taught to move in herds. Mating rituals are a reconstruction: but we infer ritualized displays, frills flashed, crests trumpeted, feather fans unfurled. Sexual dimorphism likely existed. Some bones suggest size and shape differences between presumed males and females. Growth, many dinosaurs grew fast. Bone histology, rings like trees, shows rapid growth spurts in juveniles. Some reached adult size in a matter of years, others took decades. Lifespan varied. Small feathered theropods may have lived a decade or two, giant sauropods possibly several decades. Temperament, hard to read from stone. But footprints and bone scars tell a story of aggression, curiosity, territorial disputes, and care. Some species were cautious and social, others solitary and predatory. Living attitude varied as vastly as their forms, from cautious browser to bold apex predator. Ecosystems are webs. Dinosaurs occupied threads in nearly every one. Predators and prey, theropods hunted hadrosaurs and ceratopsians. Juvenile sauropods were vulnerable to opportunists. Scavengers, small meat eaters that followed kills, cleaned the stage. In the water, crocodile relatives and niobrach-like crocodilomorphs fought for fish and opportunistic meals. Competitors, mammals, though small, coexisted in the shadows. Pterosaurs ruled the skies with wing and tooth. Ammonites and belemnites churned in the seas. Plants evolved with pressure, tougher leaves, chemical defenses, and adaptations to browsing. Ecological role, dinosaurs sculpted their world. Sauropods trampled saplings and fertilized plains. Herbivores controlled forests. Predators trimmed the weak. In many ways, they functioned like modern megafauna, engineers of landscape, vector of nutrients, a living force in ecology. Disease and parasites, they left traces, bone lesions, parasites trapped in amber, tooth marks on bone. Life was not pristine. It was dangerous, dirty, and beautifully real. Even giants are fragile. Climate ebbed and flowed. Sea levels rose, continents drifted, and climates warmed and cooled across millions of years. Ice, drought, volcanic ash, all these shifted habitats. Seasonal threats, nesting seasons brought vulnerability. Growth demands left juveniles dependent on abundant food. Disease could sweep through tight herds. Natural selection is a narrow gate. Competition was constant. New species arose to nibble a niche. Invasive plant types could change diets. Volcanic eruptions changed the skies, sometimes for centuries. Human pressures? None. Dinosaurs vanished long before humans walked upright. But if we think in analogies, habitat loss, climate change, cascading food web collapses, these ancient pressures mirror modern threats. The Deccan traps, massive volcanic eruptions in what is now India, released sulfur and carbon dioxide over long spans. These eruptions may have stressed ecosystems before the final blow. In short, survival was never guaranteed. It was a persistent gamble against changing Earth. The date always comes with a gasp, 66 million years ago. At the boundary between the Cretaceous and the Paleogene, the world changed in geological breathing, a boundary now marked by a thin, global layer rich in iridium, shocked quartz, and soot. The smoking hole was discovered in the Yucatan, Chicxulub, a crater more than 150 kilometers wide. The impact was sudden. The energy released? An extinction-scale nightmare. Firestorms. Tsunamis taller than memory. The sun choked in dust and aerosols. Photosynthesis stumbled. Food chains collapsed. Today the dominant view is blunt. The Chicxulub impact delivered the coup de grace to non-avian dinosaurs. But science is a mosaic. The Deccan volcanic pulses likely weakened ecosystems, sea level changes rearranged continents, climates were in flux. For some communities, dinosaurs were flourishing until that sudden hammer struck. Fossils recently dated from western North America and New Mexico show diverse, healthy assemblages right up to the boundary, arguing for a rapid, catastrophic end. Timeline of decline, not a slow, universal fade. Instead, a jolt reverberated across Earth. Some groups staggered, some vanished instantly in localities. Birds, avian dinosaurs, crossed the threshold. Pterosaurs and marine ammonites did not. Non-avian groups, no longer able to adapt to the cascading collapse of plant life and climate shock, disappeared from the fossil record. The last days are a hard thing to narrate without sentiment. Imagine herds in the ash snow, eyes full of something they could not name. Imagine predators, hungry, driven to desperate hunts among strangled plains. The last footprints are silent now. The last nests are fossils. The last breath is a question mark we press our ears to. It's a modern question framed in impossible terms. We are not time travelers. But play the thought experiment and the answer teaches us. Could an intervention have saved non-avian dinosaurs? Only in fiction. The scale of extinction involved global climate collapse, ocean acidification, and food web breakdown. But if we break the catastrophe into parts, we can imagine mitigation strategies: stabilize climate, protect refugia, feed the starving. None realistic with tools available then. Yet the what if is not useless. Why ask it? Because the extinction script holds lessons. Rapid, externally driven environmental change is lethal. Species forced to adapt faster than they can evolve will die. Ecosystem redundancy matters. Diverse food webs with multiple functional species are resilient. Protect keystone species today. Preserve habitat corridors. Act on climate before tipping points cascade. The dinosaurs teach, abundance doesn't guarantee survival. Size doesn't either. Agility, ecological and genetic, is often the currency of persistence. In conservation terms, modern parallels are stark. Coral reefs, amphibians, large mammals face combined pressures of habitat loss, invasive competitors, disease, and climate change. Interventions that might have helped dinosaurs, global coordination, rapid mitigation of aerosols and climate shifts, refugia, and food provisioning at planetary scale, are available in principle today for species that still live. That is the hard lesson. We cannot unmake what happened 66 million years ago. But we can use the story to inform how we choose to act now. Time folds. Beneath our feet, bones sleep. They are fragments of triumph, of hunger, of family dramas written in calcium and stone. They tell us that life is stubborn and surprising and vulnerable. They tell us that giants fell not because they were careless, but because the stage collapsed under them. And yet a part of them lives on. Birds, the descendants, carry feathers, eggs, and a rhythm inherited from their dinosaurian forebearers. Look at a pigeon, a sparrow, a hawk. Trace their bones. You will find the curve of something older. We built museums over their remains. We painted them monstrous. We turned them into cinema. But the truest cinematic truth is quieter. They were real. They lived and loved and failed, and in their failure they reshaped our world so we could rise. So close your eyes and imagine one last time. A dawn, a chorus of calls, a world of green and noise and living weight. Then a shadow falls. We remember because remembering is how we decide what to save. If this story gripped you, hit subscribe. Like if you felt the ground tremble. Comment, tell us which extinct giant you want brought back to life in our next deep dive. Which lost creature should we tell the whole story of next?